So before I begin the session, let me introduce myself. Everyone, I'm Jaimin Patel. I hail from India. I am actually having 10 years of experience in software industry. For past 3 years, I have been working in big data and Hadoop technology, and I have developed an analytics platform where we have used Hadoop, machine learning, R, and related technologies extensively, where I got my hands dirty and learned a lot in this space. Apart from that, I also possess interest in organizing the conferences with people, with like-minded people who want to share the knowledge in the same space or who are doing some innovative work in the same space. So we do a lot of open conferences in this area, and with that I also have a passion of sharing my knowledge with the people, and that is one of the reasons why we are meeting here. So I also do a lot of corporate trainings, and I take up corporate trainings in Hadoop and big data space. So today's webinar session is scheduled for 1 hour, and we will be covering, so I'll be just walking you through the agenda topics where that would be confidential, Nitin. Okay, just kidding, but I will let you know in the end. Okay, all right. So I'll be just walking you through the agenda and the course topics that we would cover today as part of this webinar session, right? So let us start discussing the agenda. So the agenda that we have designed for this webinar, we have designed it by keeping in mind that anyone who's very new in this technology, anyone who want to learn and any such technologies for the first time, right? What are the basic questions that comes into their mind? The first thing is, what is that technology and why that is important, right? So that's how we will also address this this big buzzwords. We will understand what is big data and why big data is such a big buzzword, or why industries are spending huge money in or doing a lot of investment in big data space and solving a lot of problems in that, right? So that once we understand the importance of big data, and by doing so we will also cover common big data customer scenarios. We understand how different companies or different industries are using big data to solve their business problems. Once we do that, then we get into the technologies, which are the technologies which will help us work with big data, and how Hadoop has become the most effective technology to work with big data. So that's where we understand the motivation for Hadoop. Now, in the interest of time, we would not be cover all the technical differences between Hadoop and the traditional systems, but we would try to touch base on some of the key differences which are very important and which would really help us understand why Hadoop is the most effective technology which can help us to work with big data. Okay, so that's how we have organized our seminar. What I'm trying to make sure that the objective for me in this seminar is, I want to make sure that at the end of this seminar or this webinar, I would say, everybody who's attending this webinar should be very comfortable with the what and why part of big data and Hadoop, right? So let us try to have that objective in mind, and we will begin our journey with big data space. Yeah, one more thing, feel free to ask me any questions anytime you have, and I would also tell that at the end of the session we will spend about 5 to 10 minutes where we will address questions from the audience. If anyone has any specific questions, feel free to ask me on that. Okay, all right, so let us start with big data. So what is big data? As the name suggests, right, first thing it comes to my mind is lots and lots of data, right? It's about terabytes and petabytes of data. But is this enough? Is this really a big data? If I have a huge amount of data, can I term it as a big data? So what is it really? So before I go defining it formally, or before I go giving a formal definition about big data, I would like you to go through some of these use cases that I have captured here. I'll be explaining the use cases, and by doing so we will understand what are the different sources of big data and how they are using that. Okay, so the first diagram that I have shown here is an airline industry, which says the fact says that airline jet collects about 10 terabytes of data, of sensor data every 30 minutes of flying time, which is huge, right? So I'm sure many of you are aware of that there is something called black box system in an airline jet, and that has all the sensors attached to it, which help us to collect all the data, all the event data which happens in and around during the flying time, and that could log it into the system, which basically generates such a huge amount of volume. Now these data can be used by airline industries to solve various use cases, right? And some of the common use cases that they solve is improving the performance of a flight. How do they improve? How do they make sure that their flight or their airline jet gives a cost-effective performance, right? That is the biggest use case for them to sustain in the business, and that is where they are actually analyzing these logs to make sure how do they improve the performance of a flight and make it more cost-effective. Another example or a use case is controlling the air traffic. That is also an area where a lot of airlines would actually earlier days they used to have a control system, centralized control systems, and people used to monitor that. But these days with the data, they do real-time analytics from the data which gets generated out of different airlines, and based on that real-time analytics they actually find whether there is any traffic or not. So let me give you a very similar example to this use case. I'm sure everybody uses smartphone these days, and I'm sure everybody uses GPS. So when you go to a particular, let's say when you are traveling from a location A to location B, right, and you want to know which route you are traveling, so obviously you will use GPS for that. Now when you start navigation in your smartphones, if you notice that on that route it would show you different indications, and one of the indications on the route could be, it will show the indication based on different colors. And one of the favorite indication is showing it in a red color if there is any traffic in that route, right? It will show it in a red color. Now if you think, how does it actually see, because the navigation does not work on the internet, it actually works through satellite. So how does it collect this data? How does it identify that there is a traffic? So they solve this problem by, since most of the people they are assuming that they are having this GPS enabled and they are moving in the same direction, all these GPS devices are emitting the signals, and if all the devices which are emitting the signals which are moving in the same direction and moving slowly, then there will be too many dotted points on that area, and that's where they identify that okay, there is a slow moving traffic here, or that could be a traffic because a lot of devices are in this area. And that is one way they actually predict that okay, this is the point where there could be a traffic. So that, similar to that, even airline industries try to solve this problem by analyzing. Basically gets accumulated to about terabytes of data per day. So stock exchange generates about terabytes of data every day. Now there are actually companies available in the market. Now what they do is they specializes in predicting the stock values upfront. Even before the stock market opens, before the stock opens in that market, it actually predicts how this stock is going to perform today or at this particular day or this particular time. And they do that by writing something called high frequency trading algorithms. I'm sure many of you are aware of that. There is something called high frequency trading algorithm, which is a very famous jargon these days with respect to stock trading and stock trading markets, and a lot of investors are using this technology to get more returns. Now these algorithms, to perform better, they need huge amount of data as an input. So they actually they tie up with such stock exchanges, they collect this data from the stock exchanges, and then based on that they start predicting the value or a trend for a particular stock of a company. So that's where big data is used. And again, the underlying technology that all of these different industries are using is Hadoop. So we are anyway yet to come to the point where what is Hadoop and how we do that. All right. So let me show you another example, which is a Facebook, famous Facebook, where I think this has become the integral part of most of our life, where we all use Facebook at least once in a day, right? To obviously make sure that we get socially connected with our friends and families. So I am not going to explain what is Facebook and all. But what I'm trying to emphasize here is there are some stats that is published by Facebook, which says every 20 minutes on Facebook, lot of activities happens. Links shared, events invites, friend request accepted, photos uploaded, messages sent. Facebook has about billion users, or I would say more than that, across the globe, and those users will do such activities every 20 minutes on Facebook, and in turn it will accumulate to this many number. This is the amount of data which gets generated by performing so many activities by such a massive number of users, right? And that accumulates to the huge data. So what I'm trying to cover here is, Facebook has a I'm sure everyone knows that the Facebook has a revenue model as advertisement. They have many other revenue streams, but advertisement is one of their premium revenue model. So let me just spend a few minutes on explaining how they do this advertisement. So by the way, we all use televisions at our home, right? So when we watch any particular channel or a program, a person who's sitting in USA watching a particular program, and a person who's sitting in India watching a particular program, maybe at the same time it is live stream, they may both will get to see the same advertisement which comes during that program, right? Now the person who is in India might be interested in viewing the ad, but the person who's in USA might not be interested in viewing the ad. But even in that case, both of them have to see the ad if they are watching that program. That is called mass advertisement, which means a user is not allowed, or basically advertisement is not being shown based on the user's interest, right? But Facebook has changed the way advertisement industry works. What they have done is they have done something called targeted advertisement. So with the analytics, with the help of analytics technologies and Hadoop as underlying framework, they were collecting such a massive amount of data from different users, and every user is registered on Facebook. So Facebook knows about that users. When I say Facebook knows about that user, which means Facebook knows about the details of that user, what that user do, what activities that user performs, what his or her likes and dislikes. Everything Facebook can analyze by analyzing the data that is there for that particular user. And by doing so, Facebook can actually find out what is that person's likes and dislikes, and based on that they will select what advertisement we should show to this particular user on his particular wall page, right? So that is called targeted advertisement, and by doing so For example, if someone who's interested in sports and if he's doing a lot of sports activities, he's uploading a lot of sports videos and sports photos and images, and he's joining a lot of sports events and sports groups, then Facebook over a period of time learn by itself that okay, this particular user has an interest towards sports activities. So if there is an event which is going to happen, let's say a football FIFA World Cup is going to happen in a particular city where this user belongs, then Facebook can just show the ad that okay, this is the event that is happening, and probably do show a lot of advertisement related to that. So chances of that user going and clicking those page and finally ending up doing a transaction would be much more higher than a person who's never interested in sports, right? And that answer Facebook finds it by analyzing this data using Hadoop as underlying technology, right? And you can realize that it is very important for Facebook to be very accurate in identifying this analysis. They need to find out what is the user's likes and dislikes. They should be very accurate about it. Then only they can actually materialize this revenue, right, through advertisements. So that is one such important use case where Facebook uses big data heavily and also Hadoop as underlying technology. Okay. Another similar example is what I wanted to cover is actually a Twitter example. So very similar. I don't want to spend much time here, but they also have a very similar model where they have set of users who are doing a lot of tweets on a particular topic, and based on that they do sentiment analysis of a users, and they build a set of users who are interested to do some activity. Now there is a saying that if someone wants to do a startup, I would not say saying, but a lot of states says that if someone wants to open a startup or they want to market their new product, Twitter is definitely one of the social media where they should advertise their product. Why? Because Twitter can get them the right set of users who are interested to buy this product, right? They are readily available for them, and that's where Twitter scales, and that's where Twitter makes its marks by analyzing these technologies. So that is one such use case where Twitter also uses big data and Hadoop as an underlying technology. This is the slide which explains you how unstructured data is exploding. So this is just a trend about the data that is being growing. If you can see, till late 1990s, the data volume was very less. But over a period of time, if you see that there is a hockey stick growth in this curve, which means the curve is actually growing in an exponential manner where lots and lots of data is getting added from early 2000 onwards. And the reason for that is internet is being the primary driver. Everybody has smartphones, tablets, laptops, and different gadgets through which they are connected to internet. They are every day connected to internet. They do a lot of activities on the across the globe. All the users doing a lot of activities on internet, and in turn, basically, it is contributing to adding a lot of data across the globe, right? So there is a growth in this area during this period, and a lot of companies have seen opportunity in this space to do something, and that is where this big data and analytics trend has begun. And a lot of companies thought that let us do something here, something meaningful here. Let us try to find patterns in data. Let us try to find meaning within the data to solve some business problems and remain competent or gain competitive advantage over competitors. And that is where I'll just say big data is basically 3 V's. You have volume, velocity, pardon my writing, It's very bad. And variety. Okay, so big data is categorized into three different buckets: volume, variety, and velocity. Volume, as we all know, it's basically huge volume of data, huge amount of data. It's about terabytes and petabytes of data. But can we say that if I have huge amount of data, it's a big data? The answer is no. We need to actually check more parameters to that. So there is another parameter called velocity. What do we mean by velocity? Velocity means, let me first give you an example. So let's say I will say that I have about 1 terabyte of data that gets generated in my system after every 1 year. If I say that, then so that is basically one scenario. Now let's say another scenario is I have 1 terabyte of data which gets generated into my system every other day. Okay, so in first case I am getting 1 terabyte of data in 1 year, and the second case I am getting 1 terabyte of data in every day. Now if you can see the difference, the second use case, we have the frequency of getting so much amount of data is very high. That is called velocity. The rate at which the data comes to your system or data gets generated into your system is called velocity. Okay, and the third dimension is called variety. Variety is nothing but what are the different types of data which get generated from different types of sources. So by the way, any data in the world can be categorized into three different buckets: structured data, unstructured data, and semi-structured data. Structured data means all the data that we store in relational database systems like Oracle, MySQL, SQL Server, all these different RDBMS systems that we store our data in the form of table, rows, and columns is called structured data, right? Then what is unstructured data? Unstructured data, the example that I could give you is, in Facebook, let's say, we upload a lot of photos, images, video files, MP3 songs, audio, video files, all this. These are the example of unstructured data. They are basically plain raw stream of bytes. You don't have any structure attached to it. I cannot say that get me the eyes of a person from this image. There is no proper structure to it where I can directly retrieve the value of an eye, right? I mean, I have to parse that image. So basically it's just bytes, and it's just pixels, so it's actually unstructured data. So that's one example of unstructured data. Another example could be the log files. So I'm sure you have worked on a lot of enterprise applications which are deployed in the production environment in different companies, and these applications will generate lots and lots of logs every day. Now the logs that we write in those files will not follow any particular structure, right? So that is also categorized as unstructured data. Now third type of data is called semi-structured data. The best example I could give you in semi-structured data is XML files. If you have worked with XML files are basically the files which has a parent-child relationship between the tags. So you have to first define the tags. Within the tag you define the value. The tags, or I would say the keys that you define, will have some sort of relationship, and that's why there is some structure to it. But the value that you put within each tag or each key can be anything. You can put any form of value, and that is why there is some amount of unstructured data or uncertainty is also there, and that is where on the whole it is termed as semi-structured data. Another example for that could be JSON files. JSON file is also termed as semi-structured data. So just to summarize, if I have huge volume of data, if I get huge volume of data at a very fast pace in my system, and also that data can be of structured, unstructured, or semi-structured type, then I can say I have a big data. So that is a formal definition of big data. Okay. So we understood what is big data, and we also understood some applications of big data. So till this point, are we clear? Does anyone has any questions till this point? Okay, so looks like we are fine. We are good. Nobody has any questions as of now. So I'm just moving forward. Please do stop me if you have any doubts. Okay, now we have understood what is big data. Now we want to understand why big data is very important and what are the common big data customer scenarios where companies are using big data to solve their business problems, right? So some of the examples I have already covered. Now I'm just adding few more. I have actually taken examples from different industry sectors. One of the industry sectors that I want to talk about is web and retailing industries. By the way, the use case that I have mentioned here, in the interest of time, we would not be able to cover all the use cases, but in actual training, we do that. Right now, I'll just cover a few of them which are important, and we will just understand how they solve these problems. So web and retailing industries, or e-commerce companies like eBay, Amazon, all these companies, how they use big data. So one of the best example that I could give you is there is a use case called recommendation engines. So let me tell you a scenario. Let's say if someone logs into this e-commerce company or websites, let's say someone logs into Amazon or eBay, and she has done some shoppings on that. Now she's been doing that over a period of time, and then let's say after a few days again she logs into eBay, and she would see that on the one part of the page she will see that these are the products which are recommended for her, right? So she will see some sort of comparisons of the products which is very similar to what she has done already, what transactions she has already done with this company, right? That is called recommendation engine. So what this company does is they actually analyze all your historical transaction data, and then based on that they form a opinion, or they basically try to find out the relationship between different products, and they try to answer this question that what are your likes and dislikes, and what are the products or product categories or price range that you would be interested in buying, and accordingly these companies will show you the recommendations. There are algorithms, machine learning algorithms, which are used extensively to process such big data on a Hadoop cluster and give you this answer. That is about technology part of it, but this is how they solve the use case. Now they are claiming there is a stat which says that by doing such by using this technology and solving these problems, they were able to the hit ratio of this is about 60 to 70%, which means if let's say a person who has never thought of buying, let's say today I have not made up my mind to do any shopping, but I'm just casually logging into Amazon and browsing some products, but the way Amazon recommends the products, I would be tempted to go in big data and Hadoop. Another use case I have already talked about, which is targeted advertisement. Now let me take one more use case from another different industry sector, which is telecom industry sector. So in telecom industry sector, there is a very good use case which is called customer churn prevention. Let's say there are, let me take two different telecom providers, telecom service providers, telecom service provider A and B. Okay, I'm not naming them, I just say A and B. These two companies who are a very famous, let's say very giant telecom providers in a particular area. Now, there may be a situation where some users who are using the services provided by A are not happy with them and they are migrating to the services, or they are trying to opt services provided by telecom service provider B or company B, right? Now in this case, whenever people or users who are leaving the services provided by A, they will get a call from company A's representatives, and they need to understand why are you leaving us, what is the reason, and then customers have to tell that I'm not satisfied, these are the so and so reasons and all that. Now once they do that, they will log all these reasons, and these companies will analyze this data, all the reasons, and they find out what are the top, let's say I'll just give a number, that what are the top 10 reasons why my customers, majority of my customers are leaving me. If you can see, for any business to be successful, it is very important that their customer stays with them and they don't leave them, right? So even for this use case, it is very important for this telecom companies that their customers stay with them. If they are leaving them, they need to really find out the reasons, what are the topmost reasons why they are leaving us. And once they know that, by analyzing the data, they can quickly find out that, okay, let us try to come up with better competitive offers. The reasons could be that they are not providing good services in the area where customer stays, or the competitors are providing better competitive offers at a cheaper rate, or it could be any other reason, right? So by analyzing this data, they are coming up with better offers to mitigate those reasons and make sure that in future customers will not leave because of that. That is one way of preventing your customers from leaving you and making sure they stay with you, to make sure your business is successful. So that is called customer churn prevention. And to solve this use case, mostly telecom companies are using big data and Hadoop as underlying technologies for that. Okay. So let me take another use case from another, I would not say industry, but a government, right? Government sector. Now I'll take one example, one project that is being completed or recently by Indian government. So people who are from India would know that there is something called Aadhaar card. Now this, for people who don't know what is Aadhaar card, it is like social security number in US. It's a unique identity for every individual citizen in India. So that was an initiative which was taken by government, and that has been implemented to make sure that every individual citizen of India will have the unique ID. This entire project is implemented by Hadoop as an underlying technology. Hadoop and HBase. They have used these two technologies extensively to implement this entire project. And by the way, this project is called world's biggest biometric database, obviously because of the populations of India. So that is why it is called biggest biometric database. But to handle such a massive load, they have used Hadoop as underlying technology. So that is the key point. Another use case is welfare scheme, where government, what they do is that is true with US government or any other country government, that what they do is they analyze, let's say they want to come up with a welfare scheme for a particular area. How do they come to know, or how do they decide which welfare scheme should I come up for this area and for what period, and what are the conditions to that. So to answer that question and to come up with a better welfare scheme, they analyze the GDP growth of the populations of that area, and based on that they analyze this data and come up with an answer that okay, fine, this area needs more educations or needs more infrastructure services or facilities and stuff like that. So that is also one area where government uses such technologies. Another industry sector is healthcare and life science. There are many use cases these companies adapt using big data technologies, but one of the famous use cases is drug safety. There is also a use case called gene sequencing, and I'm sure many of you are aware of that. Gene sequencing is nothing but it's called DNA profiling, which is basically used mostly in crime related cases, where if you want to predict whether the person who's involved in the crime is actually the suspect who's involved in the crime is actually the person who has committed the crime. So to answer those questions, they do a lot of such image processing, image matching, and gene sequencing on that. There is also another use case called drug safety. So specifically pharmaceutical companies who want to launch a new drug in the market, what they do is they basically take up this drug, they launch a drug in the market, they tie up with big hospitals. Now these hospitals, doctors will start prescribing these drugs to the patients, right? And obviously all the hospitals will have the data about how this drug has performed over 6 months. Now after 6 months, these pharmaceutical companies will collect the data from these hospitals and analyze this data to find out how that drug has performed and whether it has been able to cure the diseases, what is the percentage ratio, what was the effectiveness it has provided. And based on that, by analyzing this data, they find out whether to improve the drug by adding or removing particular instances or substances from this drug, or should we come up with a better version of it, or should we just drop this drug because it has never cured any disease, it was not performing well. So all these answers they are trying to come up with by analyzing this data. And again, to analyze such a massive amount of data, they are using Hadoop as an underlying technology. Okay, there is one more industry sector, and I'm sure it is favorite for many of you, which is banks and financial services. This is again one such area where big data is heavily used. So what they do is they actually try to kind of come up with I mean they use big data to solve many use cases, but I would just take one use case which is credit scoring and analysis. So in around 2008 period, right, during that time frame, I'm sure everyone knows that there was an economic downturn, and a lot of people have become defaulters to the loan that they have taken, and then bank could not recover the money from that, and that was one of the driver of the economy downturn and recession during that period. And even that time banks used to have credit scoring checks and everything, but what they did not have was analytics part of it. So after that recession, what they did is they improved that system to do analytics and do more analysis on the data. So what they are doing is, now let's say if a person goes to a bank for taking a loan, the bank can actually get all his transactional data and financial data. Whichever bank this user has an account to, the bank can, because these days all the banks are centralized, and the bank can actually by themselves by analyzing all the financial transaction data of the user, right? And that way they are making sure that they will not run into the risk by lending loan to these people. So that is also one such area where big data technologies is heavily used. Okay. So that's what I wanted to cover as part of different big data customer scenarios, and the objective of covering these use cases is to just make us realize that how different industries are using big data and why big data is so much important, such a big buzzword, why companies are spending so much money and doing a lot of investment in this space. Okay, so till now what we understood is what is big data and why it is very important, right? Why it has become such a big buzzword. Even this slide I have captured just to emphasize this fact more, that there are consulting companies like McKinsey and Gartner who are also saying the same thing, that use Hadoop to gain a competitive advantage over risk-averse enterprises. So definitely Hadoop is the key technology to work with big data, and everybody, all these companies are also saying the same thing. These are some of the Hadoop users. I have just captured some name, but definitely the list is huge. You have Google, LinkedIn, Amazon, eBay, Rackspace, Yahoo, Facebook, IBM, and a lot more users. So I've just captured few of them, few big names. Okay. All right. So since we understood the basic concepts of what is big data and why it is important, let us try to understand what are the technologies that can help us work with big data and why Hadoop is the most effective technology to work with big data. Okay. Uh, as I said, in the interest of time, we would not be able to cover in detail technical architecture and the differences about that, but I'll just try to give you some key differences here. So before that, let me just quickly brief you about initially. So traditional large-scale competitions was basically traditionally the competition has been processor bound, where you had relatively small amount of data and significant amount of complex processing was needed. So primary push was to increase the computing power of a single machine. If you can see this particular slide, you will realize that initially the data was very less, and that's why the primary push was to increase the processing power or a CPU, because they don't really have a problem of storing this data, right? They have a problem of executing the logic faster, and that's why they were increasing the processor power. But over a period of time, when this curve has been growing, this particular space has actually taken, has grown a lot. A lot of data has been growing, and that is where they started realizing the importance of storing this data in an efficient manner, and that is where distributed system evolved, right? So a lot of traditional systems like MPI and PVM were there. So since I have introduced a word called distributed file system, let me just spend few minutes to explain what is that. I'm sure many people know about that, but I just want to explain it so that people understand the basics of it. So why distributed file system? So let me give you two scenarios. One is, let's say you have one machine where you are storing 1 terabyte of data. Let's say assume that machine has 1 terabyte storage capacity, and that machine will have 4 IO channel, and each channel has 100 Mbps speed. If you want to read that 1 terabyte data from that single machine, how much time does it take? So let us not do some maths and go into that direction. Let us assume that, okay, it takes 45 minutes. Right? Now I have another scenario where I have 10 machines. I'm trying to distribute this 1 terabyte of data into 10 different machines. Each machine has the same configuration, 4 IO channel, each channel has 100 Mbps speed. Now in this case, when I want to read them parallelly, all the 1 terabyte data, obviously the time it takes is just 4.5 minutes. It is 1/10 of the time which earlier it has taken, right? That is the fundamental reason or motivation why distributed file systems are evolved, right? I'm sure there are many more technical differences, but if someone wants to understand this concept, this is the fundamental objective, or I would say motivation, why DFS is evolved. Okay. Now once we understand why DFS, let us understand what is DFS, right? So let me give you a scenario. Let's say we have a file and I want to store this file into DFS. Okay. So I'll tell you one thing. Distributed file system is not a physical file system. It is just a virtual file system. Okay. Now that means, let me explain that what I'm saying. So let's say I have 4 different physical machines. Okay. One is in Chicago, one is in Austin, one is in Denver. These 4 machines are connected in a network. These 4 machines belong to one company, right? So these 4 machines form one particular cluster. Let's assume that way. Now I have one file which has about 1 terabyte of data. That file name is, let's say, F1. Okay. When I store this file in a distributed file system, by the way, what is DFS? So DFS is just nothing but when these systems are connected over a network, all of these systems, all of these machines will have some set of programs running on them. These programs are called DFS. Okay, so I'm just kind of, putting a dotted line around these machines. So you can just assume that it's a virtual layer which is provided by DFS. But basically there are set of programs running here, 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 and here. These 4 machines will have set of programs running. These programs are nothing but they are the ones who form this distributed file system. Okay. But for an end user, they think that this is the physical storage. So let's say I want to store this file into the DFS. So what happens is this file, assume that is divided into 4 different parts. This file is of 1 terabyte size. This file is divided into Srishti, yeah, so you can just check with the Simplilearn team for that. They will have the answer for that. They'll give you more details on that. Sorry everyone, just give me 2 more minutes. I'll just coordinate with Simplilearn team. Unfortunately, uh, looks like the presenter control has been revoked, so I'll just need to check with them. Hey, can you make me the presenter, please? Yeah, looks like they have actually revoked that, so people are waiting here. Okay, meanwhile, I got one more question from Anthony. So there will be a PDF or presentation style. By the way, Anthony, uh, we actually use this for our marketing slides and webinars. So we would not be able to share that, but still I would Hello. Uh, can I quickly get a confirmation from everyone? Am I audible? Simplilearn team, they will give you the clarity on that. Okay. All right. Great. So first of all, sorry guys, sorry for this hiccup for 5 minutes. Somehow there was a technical problem and we couldn't speak or connect for a few minutes. Again, we are back. So yeah, I was just explaining you what is DFS. I'll just quickly cover that. So basically, what I was telling is you have different parts of the file stored in different machines. And for user, he has stored, let's say, a data in a particular location, let's say user/f1. He has stored that file, which is divided into these 4 parts, right? A, B, C, D. And the file name is f1. Now, for user, he thinks that I'm storing everything in this path. But when he stores the file, internally these programs which forms the DFS are actually making sure that this file is divided into different parts and physically stored in different machines who may be located geographically differently, right? Now what they do is when a user say cat, or let's say they want to view the file, they'll give the same path, user/f1. When they do that, all the programs which are running as part of distributed file system will take up all these parts of the file, right? And that will be basically presented as one big file to the user, right? So distributed file system programs will abstract the complexity of how data internally stores in different machines from the user, as well as how it is retrieved from them, right? So for user, he thinks as if like he is storing all the data into the single machine, but internally it is not. Internally it is stored in a different machine. So that is what is called distributed file system. Distributed file system is just a set of programs which gives you the virtual file system. It's not a physical file system. Okay, so we just understood this distributed file system because we wanted to understand something called Hadoop, which is also using a distributed file system as underlying storage mechanism to store the data, right? So we were understanding the motivation for Hadoop. So basically, Hadoop follows CAP principle, consistency, availability, and partition tolerance. So before I go into the details, and I think in the interest of time, we would not be able to cover all the things in detail, but I'll just spend few minutes on covering what is the difference between Hadoop and the traditional system. So there is a key difference, and we will understand that. So let's say there is a, so by the way, every distributed file system is a master-slave architecture. Okay, so let's say there is a master and these guys are slave nodes. Okay, so in traditional distributed system, when you have a file which is 1 terabyte of size, okay, and which is divided into different parts A, B, C, and D, and if these parts are stored here A, B, C, D, these by the way machines are connected through network. It's a master-slave architecture, it's a distributed file system. So I'll first explain a scenario of traditional system. How does it work is, let's say if you want to write a distributed program to process this particular file of 1 terabyte size, you as a developer submit this program to master node, right? Now what master node does is it will get all the parts of this file A, B, C, D. All these 4 parts will be transferred over a network, right, to the master node, right? So all the parts will be transferred like that. So basically you are transferring all these 4 parts, which accumulates amounts to 1 terabyte of data, to the master node, right? And that's where the processing happens. So the disadvantage here is you are occupying so much network bandwidth by transferring such a heavy load, 1 terabyte of data over a network, right? And at the same time you are not achieving the parallelization, you are not achieving the parallel processing, because all the data you are gathering in master node and then you are processing. So the problem with traditional systems were they were sending data to the nodes where computation programs are running, right? Now what Hadoop has done is they have actually done it completely reversely. So what they are doing is, instead of just do this, so instead of again there is a file, 4 parts are there. So instead of sending data to the computation nodes, Hadoop will send the programs to the data nodes. All these nodes where the data is stored, this program will be divided and sent across. So it will be like P1 is here, P2 is here, P3 is here, and P4 is here. Now you may wonder that how come a program can be divided. So don't worry about that. That is the whole beauty of MapReduce program, and in our actual training we will understand how does it work. But right now consider that the program is divided into multiple subprograms and they will be parallelly executed on individual part of the file, right? So now data is not transferred over a network, the program is sent to the node where data is stored. So that way you are avoiding this major overhead and you are not occupying so much network bandwidth, and at the same time you are actually achieving parallel processing. Once these programs process the data, they will generate partial output for all these parts, right? Once this output is ready, by the way, this is not the final output, this is just output generated by processing this individual part of the file, but we want to process this entire file at one shot. So that's where there is one more process which will be triggered, which will collect all this output, right, and then send it to one of the node. So this output will be combined together, send it across to one process which will aggregate everything and do some aggregation operation on that and generate the final output. So this is how MapReduce model works. This is how Hadoop processing works, and that is one of the major advantage what Hadoop provides in terms of processing the data, and that is where it scales very high compared to traditional systems. Okay, so that is what exactly I wanted to cover as part of the motivation of Hadoop. So, and apart from that, it follows CAP principle, but since it's already time, I would not get into the details of that. Now I'll just quickly brief about the Hadoop history. So Hadoop has evolved from about 2005-2006 time frame. So Google has published a paper on GFS and MapReduce. GFS is nothing but Google file system, and Hadoop distributed file system, which is called HDFS, is built on top of this idea, GFS. There is a guy called Doug Cutting who has implemented this concept in his project called Nutch, and then Doug Cutting was hired by Yahoo. Both of them together started a project and they gave that project a name as Hadoop. And from that they have made that as an open source, and from that point onwards companies like Facebook, Yahoo, Cloudera, all these are regular contributors to the Hadoop, right? So that is just a journey of Hadoop, how Hadoop has evolved, right? But if someone really wants to understand what is Hadoop, I'll just give you a definition, and if you remember this way, you will never forget what is Hadoop. Okay, Hadoop is a framework which allows you to do two most important things. Remember we talked about big data, right? So now let's say if someone has a big data and they want to process this big data and Hadoop is a framework which gives you the solution for these two important challenges or problems. Hadoop gives you two core components. One is called HDFS, which allows you to do storage of data in a distributed and an efficient manner, and another component is called MapReduce, which allows you to write distributed programs in an efficient manner so that they can get executed in an efficient manner and they can give you faster performance, right? So Hadoop distributed file system plus MapReduce is equal to core Hadoop. That is the definition of Hadoop. If you remember this way, you will never forget what is Hadoop, right? And all the other keywords that you would have heard about, like Hive, Pig, HBase, NoSQL, all these other keywords are all ecosystem components of Hadoop. So in our actual training, we will explain them as well. All right, so we have understood what is big data, why big data is important, and we have also understood why Hadoop is as chosen as an efficient technology to work with big data, and we introduced Hadoop as well. So that's what we wanted to cover as part of today's session, right? So there are some key characteristics of Hadoop which says it is reliable, it is economical, scalable, and flexible, and that is one of the reason why it is chosen as one of the efficient technologies. So basically all these terminologies we will explain it in detail during our actual live training sessions. Okay. All right, and that's about Simplilearn. So these are the slides which talks about what Simplilearn does and how they provide their training across the globe. It is definitely one of the leading training provider companies across the globe. It does provide training in various areas, and all these areas are listed here, right? So feel free to visit the website and check more details about that. So that's it, guys. That's what I wanted to cover as part of today's webinar session. I hope you all have enjoyed this. So I'll just spend few more minutes to take any questions if you have. Let me know if anyone has any specific questions. So if you can contact Simplilearn, they will give you more details on that. Please connect with Simplilearn team, and they will give you all the details about the prices as well. So please contact this particular email ID, and that you all should contact this email ID. You will get all your queries answered there. This is the email ID you should connect to, and he should get you all the details in terms of what are the courses available and what are the prices for big data, what are the upcoming batches of big data and Hadoop. Any more questions? Sources which generates big data and how they are using big data. We covered the scenarios of airline industries, we covered Facebook example, Twitter example, right? We covered New York Stock Exchange example, and after that we formally defined what is big data. So you need to remember 3 V's: volume, variety and velocity, which makes up big data. After that we started with why big data is important. So we have covered common big data customer scenarios where we understood different industry sectors and how they are using big data to solve their business problems. We have taken use cases from retail, e-commerce domain, from telecom sectors, from government, from finance sectors, from healthcare industries, right? And once we understood the importance of it, we started understanding what are the different traditional systems available which can help us work with big data. And that's where we understood what is distributed file system and why it is important. Once we understood that, then we also understood the difference between Hadoop and traditional distributed system in terms of how they processes data. And that's where we understood that Hadoop takes programs to the nodes where data is stored, and that's where it actually achieves the parallel processing, and it gives you faster performance in terms of processing the big data, right? And after that we understood some characteristic of Hadoop, and we introduced Hadoop, and then we formally define what is Hadoop. So Hadoop gives you 2 capabilities. One is storing the big data in a distributed manner and then processing the big data in a distributed manner. So that's what Hadoop is all about. So that's what we have covered as part of today's webinar session. Oh, I see. Okay. Well, I apologize for that. Seems to be something wrong with the time zone. So you should definitely send your feedback to the Simplilearn team. As I said, it would be I would not be the person who can confirm on that. So all your queries related to course materials and training should divert to the email ID which I have shared in this session. They'll be able to help you with that. Okay. So I hope all of you have enjoyed this session, and I hope you found it a good useful of time. Right, so you can get the contact details from the Simplilearn website.